This is the first in a series of factoring videos. So this is looking at factoring trinomials where a equals 1. So that would be factoring trinomials of the form x squared plus 7x plus 12. There are a million different ways to factor, and there's no one way that is better than the rest. It all just depends on what works for you. Some people like to guess and check. Some people like to use some crazy method they made up. You can Google factoring and you're going to find a plethora of things. But I'm going to show you one sort of based on the area models that we looked at when we did distribution. If you start seeing patterns and you want to change what you do, you can definitely do that. So I have x squared plus 7x plus 12. If we think about area models, we would have had an area model for this with 4 rectangles in it. We knew that the x squared always goes in the top rectangle. The 12 is down in the bottom rectangle. And that between the two middle ones, we should have 7x. That's what we're going to look for. So what we're trying to find here is x and something, x and something. We need to find those two numbers. Well, if we're looking at our area model, we can see that those two numbers need to multiply to make 12. Those two numbers also need to combine to add up to get us that 7x. So basically, we're looking for numbers that add to be 12 and multiply, that multiply to be 12 and add to be 7. Multiply to be 12, add to be 7. I don't want to have to start over. Alright, so multiply to be 12. Let's start at the very beginning. 1 times 12. Is 1 plus 12 7? No. Okay, moving on. 2 times 6. Is 2 times 6 7? No. Moving on. 3 times 4. Is 3 times 4 7? Yes. So we have our missing factors. We have our missing numbers. We know that this needs to be 3x and this needs to be 4x. So the dimensions of our rectangle, or what we would fill in on the outside of our area model, are x and 3 and x and 4. So to write your final answer in factored form, you just write those two sides factored, in factors, in parentheses. X plus 3 times x plus 4. We factored the trinomial x squared plus 7x plus 12. Now let's see about factoring x squared minus 3x minus 10. This is where things get a little bit trickier because we're dealing with negative numbers. I'm going to draw my rectangle again and get it all set up to go so I can see what I'm working with. I've got x squared in the top, I've got negative 10 in the bottom, and I know that together these guys need to add up to be negative 3x's. So I already know that this is going to be x and that's going to be x, and I'm looking for these two blanks here. We're looking for numbers that are going to multiply to get me that negative 10. And then when I combine the two numbers, they're going to need to add to be negative 3 when I combine them in the middle. So let's think of some numbers that might work. We know numbers that multiply to be negative 10, negative 1 and 10. Is negative 1 plus 10 negative 3? Nope. Okay, negative 5 and 2. Is negative 5 plus 2 negative 3? Yes. So we found our solution. I just want to throw this out here while we're talking about this problem. What if I had stumbled upon negative 2 and 5? That adds up to be positive 3, which does not work. However, it gives us a clue that all we need to do is flip our signs. So negative 5 and 2 are our solution numbers. That means one of our blanks is going to be negative 5 and the other one's going to be 2. Because that would get me negative 5x's and 2x's, which adds up to be negative 3x's. When we write our final solution, we're going to write those two sides of the rectangle out in factored form. X minus 5 times x plus 2. x squared plus 11x plus 24. I'm going to draw an area model. I hope you guys start picking up on the pattern of what number we need to multiply to be and what number we need to add to be. So we have x squared, we have 24, and we're going to try to find some numbers that combine to equal 11x's. So now we need to thinking about our numbers. If we look at our area model, we see the two missing numbers need to multiply to be 24. And those two missing numbers also need to add up to get me my 11x's. So now we need to start thinking of factors of 24. Once you start getting better at this, you're not going to need to just start at 1 times 24, because in your head you can think, oh, it's not going to add to be 11. So you can start at something more in the middle. I'm going to try 4 and 6. 4 plus 6 is 10. Close. Doesn't work. Okay, how about 2 and 12? Definitely not going to work. 3 and 8. 3 times 8 is 24. 3 plus 8 is 11. So I found my blanks. That means we are going to have 3 in one blank and 8 in the other. It doesn't matter which. Which means we'll have 3x's and 8x's. If we check this, yeah, it does work out to be 11x's. So our final factored form of this expression, is x plus 3 times x plus 8. Here's another one with a negative in it, which means we're going to have to think quite a little bit more about those numbers we select. We know that we are going to need numbers that get me a 28 in the bottom corner. And then these two middle rectangles need to add up to equal negative 11x. So these two missing numbers that we're thinking about, the two missing numbers we're going to use to make our table, what do you think they need to be if they're going to multiply to be a positive but add to be a negative? Two numbers that multiply to be a positive 28, they're multiplying because they're the two sides there, and add to be a negative 11 have to both be negative. So let's just start thinking about 28. Numbers that multiply to be 28. 1 and 28. But they would both need to be negative. Still doesn't work. 4 and 7. But they both need to be negative. Negative 4 plus negative 7, that's negative 11. So I found my solution. That means we are going to put a negative 4 in one blank, negative 7 in the other. So that gets us negative 4x and negative 7x. So we have x minus 4 and we have x minus 7. By now, some of you guys have probably picked up on what we're doing. We are multiplying to be the last number, and we are adding to be the middle number. So you don't have to draw that rectangle once you get better at figuring out. Multiplying to be the last number, adding to be the middle number. We thought we were so clever, we knew we multiplied to be the last number and added to be the middle number, but this problem doesn't have a middle number. Uh-oh. I'm going to draw an area model just to help me figure out what that middle number could be, should be, would be, whatever. X squared and negative 64. So these guys right here in the middle actually add up to be 0 x's. So we could say that this is the same as saying x squared plus no x's minus 64. So what we're doing is we are looking for numbers that multiply to be negative 64 but add up to be nothing. Think about numbers that would add up to be nothing. They're actually going to be opposites. So numbers that multiply to be negative 64 but are opposites, 64 is 8 times 8. One of them has to be negative, so we get negative 64. So negative 8 plus 0 is, negative 8 plus 8 is 0. So we found our two blanks. It means we're going to have x and negative 8 on one side, and we're going to have x and positive 8 on the other side. That gets us 8x and negative 8x, which for sure do cancel. And we're going to write our final solution in factored form as x minus 8 times x plus 8. This is a special case. I'm going to do a whole video on special cases. That's known as the difference of squares, because it is the difference of two things that are perfect squares, x squared and 64. But you can see that even if I didn't know it was a special case, I can still use my same factoring method to get it into factored form. X squared minus 14x plus 13. We need to multiply to be 13, and we need to add to be negative 14. I knew this because if I were to draw my area model, the 13 would be in the bottom corner where the two blanks are multiplied together. I'm looking for these middle ones that combine to add up to be negative 14. So if they're multiplying to be a positive number and they're adding to be negative, that means they both have to be negative. Think about numbers that multiply to be 13. 1 and 13. That's about it. But if they're going to add to be a negative 14, they both need to be negative. So we have negative 1x and negative 13x if we were going to fill in our area model. So our two factors are going to be x minus 1 and x minus 13. Now let's say I wasn't sure if I did this right. This is a tricky one. It's got 13 in it. It's got lots of negatives. I could check my solution by distributing it back to see if I get the right thing. So remember your double distribution. This gets us x squared minus 13x. And then when we distribute the negative 1, we're going to get negative 1x and positive 13. When we combine like terms in the middle, we end up with x squared minus 12x plus 13. So this is a way for us to check to see if our factored form is correct. And in this case, it was. We need to just do the opposite, go backwards, and use distribution to see if our answer is actually correct. Okay, last example we're going to look at is x squared minus 6x plus 9. We're going to look for numbers that multiply to be 9 and that add together, combine together to be negative 6. So numbers that multiply to be 9 are 1 and 9. But they have to add to be negative 6, so not going to work. Numbers that multiply to be 9, 3 and 3. They add to positive 6, though. But what if we make them both negative? Yay, it works. So that means our two factors are going to be x minus 3 times x minus 3. We can write this one as a single factor, x minus 3 squared. If you remember from when we were doing monomials and double distribution, you see something squared, it just means that thing to multiplied by itself again. So x minus 3 all squared is the way that we can write the factored form for x squared minus 6x plus 9. I want to throw one more out there because I have a little bit of extra space and it's a good idea to get you guys thinking about multiplication facts. Let's do x squared plus x minus 12. The number we're looking to multiply to be is negative 12. The number we're looking to add to be is positive 1. Multiplies to be a negative, adds to be a positive. That means one's negative and one's positive. Numbers that multiply to be 12, 2 and 6. Is there any way I can arrange a negative sign to get positive 1 left over? Nope. How about 3 and 4? Which one of those would have to be negative to get me a positive 1 left over? It would be the 3. So we have negative 3 and positive 4 as our two solutions. What are the two numbers we are missing? When we write our answer in factored form, we're going to write x minus 3 in one factor and x plus 4 in the other. If we wanted to check our answers, we could use double distribution to go back to see if we ended up with x squared plus x minus 12. So this is just one method that you could use to factor. Not saying it is the best method or the only method at all. There's so many methods out there that it really is a personal decision. Remember though that once you get it into factored form, you always need to go back and check by using double distribution. See if you end up at the same original expression. If you did, you factored it correctly. So remember, this was the first of many factoring trinomial videos, so keep an eye out for some of the others as we start tackling more challenging trinomials.